So, hi everyone, my name is Yoon. This is my talk. Oh my God. Okay, so, all right, thank you. So, I'm going to be talking about infrastructure as code and how it's a must-know skill now for today's developers. So, who am I? My name is Yoon, as I just said, and I work at NBC Universal as a software engineer. And I'm also known as the Dallas Software Developers Meetup Group, like Cookie Lady. And at the end, I brought some cookies so I can pass them out later. So, bribing you guys. So, before I start my talk, I wanted to ask, who here is trying to get their first job in tech? Okay, so it's like half the room. And then I want to ask, when you start looking at your job listings, have you ever seen the words like AWS, Azure, CI/CD, Terraform, or like containers? And then who here has a job in tech and is working already? Oh yeah, it's like an even split. And then from y'all, like in your day-to-day work, do you use any IAC tools? Yeah, like a good chunk of y'all. Okay. So as you can see, nowadays IAC is pretty commonly used, even though it's deemed as DevOps, but it kind of expanded upon that because of the cloud adaptation that is widely spread throughout all the companies lately. So I will be telling you why you should probably learn it if you want to be competitive in this job market. So what exactly is IAC? IAC, by the definition from AWS, is the ability to provision and support your computing infrastructure using code instead of manual processes and settings. So what this means, instead of directly creating something on like the console, you are writing something with code, quote unquote, and then you're basically telling something to build this for you on whatever cloud. And then there's two different types of IAC tools. There is declarative and imperative. Declarative is the one that you'll see most often because in declarative, you define what the final state of what you want. You don't tell it how to build it. You don't tell anything like in between. You just want like, I want this, and then it'll do it for you. And some common examples are Terraform, AWS Cloudformations, Pulumi, and then probably all the ones you've probably seen are probably declarative. And then there's imperative. Imperative is basically you have to give it all the steps, and it's very granular to get to that final outcome. So this way, it's a bit more complex, a bit more advanced. And honestly, I've personally never seen it used at a workplace, but Chef is one of the programs that you can use if you want to go this route. But the most common way is definitely declarative. So why does it exactly matter in today's developers? So there's this whole modern work expectation where cloud is everywhere. Like if you look at any job listings, they always list cloud in there, whether it be AWS, Azure, or GCP. So if you want to be working in that setting where you're working with modern technology, because I know that's like the new shiny thing, right? Like you probably went to boot camp or something and you're looking for your first job. You want to work with the latest tech. You want to do the shiny stuff. But if you want to do the shiny stuff, it's probably modernized on the cloud. So that's one thing. And then the next thing is that it bridges the gap between code and development. So when you're working in a work setting, you have multiple environments. You're not just having like prod and that's it. I mean, I guess you could, but I don't recommend it. But the normal settings is usually there's a dev, like a stage, maybe a QA, and then there's also prod. And these environments typically mirror each other. So the easy way to do that is using infrastructure as code, and you just deploy it into multiple environments. But that way, you know, your resources are consistent in every single environment. And by doing that, you have that consistency and you know it's consistent. So you have a better ability to debug and like troubleshoot before it even gets to prod. So less downtime in prod, and less issues, essentially. And then that kind of goes with my next point, where it promotes consistency and automation because of that consistent resources in every single environment. It's pretty easy. You just write like a template and then you throw it out for every single environment. And then also tied to that, like I said, like the keyword like CI/CD, infrastructure as code and CI/CD pretty much go hand in hand. Your infrastructure as code is a file. It's like a code file. You push it to your repo, and then it technically triggers a pipeline, and that pipeline will include those resources. In that pipeline, you'll build your resources, and you'll also deploy it. So if you want to get into the whole like automated prod releases, you've probably heard that like buzzword all the time. You'll have to use IAC. And then lastly, the developer and the team itself, you'll also get an increase in efficiency, because before it was the DevOps team or the cloud team that were making these infrastructure for you, and you would have to wait. You would like submit a ticket, be like, I need this resource. Who knows when they're actually going to build it for you? It could be like tomorrow. It could be 6 months from now. You never know. So you don't have that dependency of having to rely on another team. You can just do it yourself, and you won't be blocked by that. So what exactly is Terraform? So Terraform, like I said, is a declarative IAC tool. It's written in HashiCorp configuration languages, it's HCL. And I know it's a little spooky that you have to like learn another language, but I promise you it's pretty straightforward. If you can read English, you've probably got most of it already. So as you can see an example, that's literally HCL. Like if you just read it, it's pretty straightforward. It's nothing super complex. And if you just go like online on hashicorp.com, they have really intensive documentation with examples of how to do pretty much every resource available on all the different clouds. One of the things that Terraform is really known for is its multi-cloud support. So that's probably one of the biggest things about it, is that it is cloud agnostic. So any team that uses a multi-cloud structure will benefit greatly from Terraform, because you would only need to use one tool and you can deploy it to every single cloud. And another nice thing about Terraform is that it does state management for you. How Terraform does it exactly is that it creates a specific state file for you, and then you can store that state file, whether in like an S3 bucket, your repo, etc., any type of storage. Also, say like maybe you got like a new junior on your team. They're not fully aware of what IAC is. So instead of configuring and updating the resource via Terraform, they go into the cloud and they just like manually adjust it. Well, the state can actually detect any drifts. So if you know something got changed, or you didn't even know something changed, it'll tell you that something got manually changed and let you know to like fix that. And one of the biggest benefits that you have with Terraform is that you plan before you execute. So one of the biggest things about Terraform is that you can do Terraform plan, and then you can do Terraform apply. So these are CLI commands, basically. In Terraform plan, what it'll do, it'll compare the state of what it is already done and all of the changes that you want. It'll compare that and tell you what exactly is going to change, so you can see what's going to update, how it's going to update, and what the values that are updating are. And then if you see any mistakes, then you didn't apply it yet, so you're good. Like, it's just there as a draft. And then once you're secure that everything is how you want it to be, then you press apply, and it'll go and shoot it off into cloud and do whatever magic there. And now infrastructure lifecycle management is. So Terraform gives you ability to create, update, and delete. One thing that's nice about this is everything can be done as like a whole for each Terraform stack that you create. And because you can do it all as a whole, you won't leave any like straggling resources behind, because you guys probably all have heard the horror story. Like if you do like an EC2 instance and you just forget about it, and then you get charged like thousands of dollars at the end of the month. With Terraform, you don't have to worry about that because if you press delete, it'll make sure it's deleted. And then lastly, Terraform promotes an immutable infrastructure. So instead of manually having to change everything, all you have to do is configure something and put that update and then push it. So that it wants you to get into the habit of that instead of actually manually doing anything on the console. Then we have, what is AWS Cloudformation? So this is another popular tool that's used, but as you can tell by the name, it's very native to just AWS environments. So if your company or your project is pretty much only using AWS, this is a good choice because I would say it's pretty beginner friendly because it's written in JSON or YAML. You don't have to learn a new language. And I'm pretty sure all of you guys know what JSON or YAML is. And that's because it's AWS native integration, anything that changes with AWS, whether it be a new update, a new feature, et cetera, CloudFormations will get the first support. So you don't have to worry about does Terraform or Pulumi, et cetera, is this actually getting supported yet? CloudFormations will do it right away. And then the way with state management, like I said in Terraform, you have your own file that you store. CloudFormations doesn't really do that. It kind of does everything for you. So AWS is very famous for they'll do it for you and like take less work, like make you do less work, and they'll do it all behind the scenes for you. So what they do is they have this like CloudFormation smart thinking. I don't really know what the exact word is, but it will basically keep it in mind in the back. And then when you have your resources listed, you don't have to write like, oh, well, this has to build first, and then you can do this. CloudFormation will automatically figure it out for you and then do it in the correct order. And that's a part of like the infrastructure lifecycle management. Like you don't have to worry about like, oh, well, how do I make sure X comes first? And then this one, like if I wanted to make a database, I probably need the proper permissions first. It'll create all of those permissions and then the database. And then you also have the ability to see everything in a nice, neat stack on the console. And you have the ability to just create, update, and delete everything all at once, kind of like Terraform. You also can see change sets and resource imports. And these are all like, if anything got manually created, you can automatically put it into your CloudFormations template and just make it match. And then automatic resource dependencies handling, with the same thing I said earlier. And then cost management. So before you even apply your settings of what you want to be deployed in AWS, you can actually do a cost estimate on AWS to see what these potential things will cost. So these are some recommendations of what you should probably learn on top of IAC, because IAC is built upon these foundations. So like cloud provider basics, you should probably know what resource you want to do, right? But you don't have to learn everything. Because, for example, like if you're front end, you're not going to use everything out there. Like AWS, Azure, GCP, so many resources. You don't have to know every single one of them, but there are probably common ones like an S3 bucket. You're probably using that for storage. So learn what's common to what your job or your stack is. And then also, you should probably learn about identity and access management, because you need to understand permissions and how they go hand in hand with resources. And then networking basics. Cloud is literally built on networking foundations. So if you're not understanding like what is IP address, what are subnets, what are load balancers, you're going to have a tough time writing proper IAC. So I do recommend you don't have to learn everything extensively, just learn the foundations. And then because if you want to do automation, you should learn about CI/CD pipelines. A free one that you can do is like GitHub Actions. And then lastly, Linux fundamentals. Linux is really dry, I'm not going to lie. But it's pretty important if you're going to use the cloud, because there will be times that you're going to deploy something and you want to troubleshoot it. And how are you going to do that? You have to SSH into their little instance. And that's all in Linux. So you should probably learn the fundamentals of that. And I know I learned it too. It was not fun, but there's a game you can play that I actually do recommend. It's called the Bandit game, and it's on overthewire.org. And it's a game you can do to learn all of these Linux commands and how to like go around in the terminal. And that's one way to do it. And I do recommend that instead of just like reading a book. And yeah, that was my presentation. Do you guys have any questions?
I have a question.
Yes.
So you mentioned about the CloudFormation, it creates all the rules.
Mm-hmm.
Does it create all the IAM rules and roles?
It won't create it for you, but if you define it within like your template, it'll do like an order of like, I'm going to make this role first because this thing is dependent on that role.
Like in the UI?
No, just like CloudFormation itself will like automatically do it for you. Yes.
Let's say I'm already in the cloud and I want to use Terraform to then keep it as code. Is there an easy way to take what I already have set up and networked and wired together and make it in Terraform code?
I believe Terraform has a thing similar to CloudFormations where you can take like manual things and like import them into Terraform. So, but I could be wrong, but I think there is. Yes.
If you're all AWS, are there any advantages to using Terraform over CloudFormation?
I think Terraform is pretty much the industry standard. So I wouldn't say it's like an advantage or like a disadvantage. They both have their quirks and they both have their annoyances. But
If I may,
yes.
no, if I may add, don't use CloudFormation.
I would say Terraform is pretty much the standard because Terraform is a skill that every company will use. Every company will have a Terraform somewhere used, maybe not on the current team that maybe you're looking at, but another team will be using it. So I think as an industry as a whole, Terraform is probably the most widely used, but they're all both basically the same. Like the core concepts are the same. So if you learn one, you'll pick up the other really quickly.
How many resources can one person manage? For example, how many resources are you managing?
I think my team, our CloudFormations, we're using CloudFormations and we're using AWS SAM specifically. I believe we're managing about 400 resources in one file. It's a very large file. I think it's like 6,000 lines of code, but it's a lot.
Follow-up question.
Yes.
6,000 of lines. How do you debug it?
So don't follow what my team does. I don't recommend actually doing one file. But you can do like a nested structure of like, I want these specific modules in like this file and this one, this is like the parent. So you can have that child and parent relationship in these IAC tools. You can do it in Terraform, you can do it in CloudFormations. Every IAC tool is like that, but yeah, don't follow my team's example. Not the prime one here. Oh, yes. Are you sure? All right. Cookies. See, I'm here to bribe you guys, so.
I have one more question.
What?
Did you enjoy this?
Oh my God, like, why did you guys do this? Oh, yeah, I'll just like, I'll go through real quick. No problem. Okay, hold on, stop. How do I stop this? Leave studio?